So in this video, I'll be going over the code I created for the VEX IQ robot to complete the autonomous section of the competition. Before you jump right into the coding part, there's several things you need to do, which include the renaming of your program. So you just click this rectangle up here, click rename, you save it to your, and that's it. Next step you want to do is choose what slot this program will be saved into your robot, because sometimes you may have numerous programs and you will not want to save in the same slot, because saving in the same slot means it will delete the previous code saved on that robot. So if you make a new program, make sure to always click a new slot. That way you have it all saved on your robot. So the next thing you want to do is to go on the top right of your screen and click this motor looking button. This will give you all the things that you can do to add a device, such as a controller, motors, or any sensors you have connected to your robot. So since I already have it all done, but I can just add a new motor. Let's say I added a fifth motor and I wanted to add it to port 2. I just select port 2 and then it takes me to this new page where I can rename the motor. So let's say this was my arm. I'll just do arm 2 since I already used arm before. And then I can also change the polarity of the motor down here. So if I wanted to make one side the forward direction, the other side reverse, and I just click this button. And click done, and that's it. It's already down here. Now if I wanted to add a sensor, it's very similar. Let's say I wanted to add a touch LED. I just select another port. And sometimes it renames it for you, but if you want to just have your own name, just put LED and click done. And there you go. You got the two new things you added, and I have everything else on here. So I have my drivetrain motors, my arm, my claw, the distance sensor, the optical sensor, and the VEX IQ robot brain. Make sure you click on the second generation. And that's about it for this. So once you have all three things done, then you can move into your code, which is all of this I have created. So I broken up my code into different sections. So this first section will be setup. This is where I will set up all my variables, my motor positions and speeds, its braking. I'll also set up my optical sensor. The next important section will be the main code. This is where the majority of the code will be running in the robot before it gets broadcasted, and then it will switch to searching for the color. Down here, these two, this one and this top one, are called my VEX. What these are is my own blog I've created to condense my code, which I'll talk more about when I get into it. And these last two would be when I receive messages. So while the code ends, it will broadcast color sense, and these will receive the message color sense, and it will run two different codes. This one will be driving, which I'll talk about it later, and this one is to detect what color it detects on the strip. So to begin with, on setup, I have multiple things. The first thing is to set the drive heading to 0 degrees. Just make sure the robot is always straight. The next part is setting the arm position to 0 degrees, its velocity to 50%, its stopping to hold to make sure when the robot is not moving the arm, it will maintain its position at all times without dropping to the floor. And the last part is its max torque 100%. So since the robot arm is really long and just the claws on the other end of it, it might not be able to pick it up due to its weight. So I have the max torque 100% so to make sure it picks it up, to make sure it has enough strength to pick it up. Next, I have my drive stopping to hold. So whenever the robot stops moving, it will make sure the wheels lock in place so it doesn't shift around. Then I have the set drive velocity 30%. Make sure it's pretty slow because if it goes any faster than that, it might mess up its autonomous. And the turn velocity will be 40%. After that, I have the set claw velocity to 100% because that could be as fast as possible to grab the disc pretty quickly. Setting the distance sensor to the distance it detects right off the bat. So what this block does is it measures, the distance sensor measures how far it is from the wall, and it will set the variable distance to that number. And the other variable I have is set wall sensor to 23. And this will be used later on over here in my code. And the last thing is setting up my optical sensor. So I just turn on the light and set the light power to 100%. Next, moving on will be the main code, which, as you can see, consists mainly of these little pink blocks. What these are called are my blocks. I've created my own blocks down here where it says my blocks. And the way you do that is by just clicking on make a block. You type in whatever name you wanted. So I'll just put MESA. And you can add different inputs, such as the oval, the diamond-shaped one, or just add text. And what these are for is to condense my code in order to make everything more readable. Because if I were to add this and replace it with the score block, then it'll make everything really long. And depending on how many scores I have, then it'll make it a lot longer. It'll be reaching all the way to the bottom. Same thing for this one. If I do copy this and replace it for cycle, it'll be multiple layers downwards and it'll just be hectic. So that's the whole reason I have these my blocks to condense my code, and it's a lot easier to read. So in my main code, the first thing the robot will do is spin the arm to position 30 degrees. As over here, I first set it to position 0 degrees. That way, when the robot starts, it knows where the arm is located. And telling it to go to 30 degrees is telling it to move the arm up just by a little bit so it doesn't drag on the floor. And once it's up, it waits 0.3 seconds. There's a delay. I have delays around my code in order to help the robot be more efficient and score effectively, because if I don't have any delays, then I will do all of the tasks immediately, one after the other. And the downside for that is that it would just not work. It would either wobble a lot, jolt, turn when it's not supposed to, or it would just completely miss the disk into the ring rack. So that's why I have these delays around the code. So after waiting 0.3 seconds, then it spins the claw forward, and the forward direction is closing it. So after it closes on the disk, then it will do score, which is down here. So what score consists of is the different movements the robot needs to do in order to score into the ring rack. So the first one will be to spin the arm to position 800 degrees, which is spin it almost all the way backwards and score it and place the ring on the ring racker. Then I have stop claw because as you seen previously up here, I have it to spin forward, but I never told it to stop. And the reason I have it to stop a lot later is because if I had it stop, if I move this block and put it up here, right after this, then the robot will have no grip on the disk. And when it moves to 800 degrees backwards, then there's a good chance the disk might fall. So that's why I have the stop claw button after it rotates 800 degrees. Once it has stopped, then I have the spin claw reverse in order to let go of the disk and actually score it into the ring racker. After that, there's another delay of half a second. I have it's to stop the claw because I don't need it to keep opening once it has let go of the disk. have another delay, and then spin the arm back to 30 degrees in order to be just hovering above the ground so it's not dragging. So once it completes that, then it moves it back up here and moves on to the next block, which is cycle. And that's where this one comes in. So what cycle does is it tells the robot when to move forward and when to move back to grab the next disc and detect how far it is from the wall. So in my cycle code, I have a repeat until loop. What this loop does is it has code inside it that will repeat forever until the criteria on top of it is met. So in this case, it will be driving forward forever until the wall sensor variable is less than or equal to the distance that the distance sensor is detecting. So wall sensor currently is set to 23 inches. And what that means is that whenever the robot is 23 inches or more away from the wall, then it will stop driving forward. And as you can see here, I have this little turn to heading 0 degrees. What I've done is tell the robot that every time that it's not facing 0 degrees, facing forward, it will turn again towards 0 degrees. So let's say your robot is veering to the right or to the left, or it gets stuck on the carpet and it just completely turns. This little turn to heading 0 degrees will tell the robot to go back to 0 degrees and correct itself. So it's always driving forward or back and in a straight line, which is really helpful. So I suggest if you guys are doing any loop to drive forward or backwards, you should include a turn to heading 0 degrees or turn to rotation 0 degrees. Either works. So once the criteria is met up here, it exits the loop and the robot stops driving because that's when it knows that it has reached more than 23 degrees. I mean 23 inches. Then it will wait half a second and spin the claw forward. Spinning the claw forward again closes the claw to grab onto the disc. Waits half a second and spins the arm to position 50 degrees. And the reason I have it to spin a little bit higher than 30 degrees to 50 is because once it has grabbed the disc, we don't want that disc to drag and create any friction that will let go of the disc. So that's why I have it to set the arm position to 50 degrees so it raises the disc just above the ground so it's not dragging. Then I have it to wait another half a second and go into another loop. And this loop is almost the exact same as this one, just the opposite direction. So it will repeat forever, it will drive reverse forever until this criteria is met, which would be when a distance is less than or equal to the distance variable. So the distance that the distance sensor detects has to be less than or equal to the variable, which originally the variable was set to how far the robot was originally from the wall. So when you first started the robot, it immediately in the setup knew how far it was from the wall, which let's say it was 10 inches. So over here, it will wait until the robot is less than 10 inches or equal to 10 inches away from the wall before it exits the loop. Same thing I have here, drive reverse and turn to heading 0 degrees. So make sure it's always going in a straight line. Once it's done that, it exits the loop and stops driving. And the last thing it does is change the wall sensor by 7. So originally wall sensor is 23 inches. And that is because the first disc that is already marked on under your field would be 23 inches away from the robot. So changing the wall sensor by 7 at the end of this cycle code would be adding 7 towards the number that you have previously set in your code. So since it's 23, adding 7 will make it 30 inches away. Meaning that the next time this cycle code runs, which will be right here, it would be traveling further away from the wall in order to grab the second disc that's already placed. And it will continue doing that for every loop until it is finished. So this first one is 23 preset. The second one is 30 because 23 plus 7 is 30. And then the third cycle would be 37 inches away from the wall to get that last disc. And that's how you would be consistently getting your disc and not having such a long code by using your MyBlocks. And as far as for score will always just be the same once it has reached a certain distance away from the wall. Then it will just do the same automated movements in order to score the disc into the ring racker. Once a robot has gone through all of these pink blocks, MyBlocks, then it will broadcast a color sense message. And what this color sense message does is it stops running everything else and goes straight to here. And so what these two blocks does is, these two codes do, is this one's for driving. This will be in charge of telling the robot where to go in order to look for the colored strip. And this color sensor message will run a forever loop in order to look what color as detected. So I'll start with this one. So once it has received a message color sense in a forever loop, it will do 3 if statements forever. So the first if statement is if the hue of the optical sensor is greater than 245 and less than 260, then it will change count by 1. And originally count was set to 0. So over here count is set to 0. And over here in this code will repeat until count is equal to 1 or greater than 1. So what this does is whenever it detects blue, green, or red, right now I don't have the hues for green or red. That's for you to figure out because the sensor will be different depending on the lighting or the type of carpet you use, as well as just general the sensor might be a little off. So that's for you to figure out. So depending on what color it detects, it will change count by 1, and changing it by 1 will tell this code that it has found a color, and it will exit this loop. So I'll just walk you through this code. So when it first receives a message, it will turn to heading 90 degrees. So it will do a completely right turn, 90 degrees, and then it will enter this loop that repeats forever until count is equal to 1 or greater than 1. Then in this loop, it will drive forward until the criteria is met, and once it is met, then it will stop driving and play sound, which it could be any sound. I have it set to the wrong way. And yeah, so just to recap, so when it exits the main code and broadcasts color sense, the robot will turn directly 90 degrees to the right. It will repeat driving forward until it has detected one of the 3 colors. And I also forgot to mention, but I have this turn to heading degrees as I have had it up above or turn to heading 0 degrees. That is when you want the robot facing forward, but because the robot is turning to 90 degrees to the right, instead of being 0 degrees, you have to have it at 90 degrees because the gyroscope will be reading 90 degrees when it's driving forward in that direction. So just be careful of that depending on where you want your robot to be facing all the time. And once I detected any of the 3 colors, it will stop driving and play the sound. And yeah, that's it for my explanation of VEX IQ code for the autonomous period.